All right, now that we have a compute instance set up, it's time to go ahead and create our first machine learning pipeline. Now, this isn't going to be a complete machine learning pipeline. We're just going to start with some basic pulling in data and doing some summarizing, maybe a little bit of transforming just to get the flow of things. Now, there's multiple ways to access most objects in here. We're going to start here in authoring, and we're going to focus primarily on the designer. The purpose of the designer is to give you a no-code option that is somewhat customizable. So, for example, creating a notebook is a way to write Python or R code from scratch to create and entirely customize the pipeline. AutoML is another way to come in here and just simply give it access to a data set, point to the label or whatever it is you want to predict, and then it'll automatically try every combination of features and algorithms that are possible and help you pick the absolute best one, the most accurate one to predict or make whatever prediction is you're trying to come up with. The designer, and this is a completely no-code option. However, it's a bit of a black box. It doesn't let you customize a lot. It just gives you a lot of different runs and says, here's the best one. The designer's kind of in between notebooks and AutoML. It will let you actually use these pills, which we're going to learn about, which are kind of code blocks, but you don't have to look at the code or write the code, but pills of functionality where it'll bring in data, clean data, model data, evaluate, score data, and let you build a complete pipeline that way. The advantage is you may have some domain knowledge or theory about what features are best to predict a certain label. AutoML, it will tell you what's best. The problem with that is, what if your data set is biased in some way and not a perfect representation of what your future customers or employees or whatever your cases represent in the data set you're interested in? What if that's not going to represent the future perfectly? Well, in that case, you don't want to let it automatically pick the best features because those will change over time. Or maybe you have a good theory that says, all right, despite what this thinks, I know what's best. The designer will give you complete control over which features you use and which algorithm you use, but still does not require you to write any code. And that's kind of a perfect environment to learn in because it lets you learn all the underlying details and processes that go into a machine learning pipeline without having to write the code yourself like notebooks. Anyway, that's why we're going to use the designer. So let's go ahead and create a new pipeline. And it says, all right, here's the current title. Let's give this something else. We're going to, I'll call this the Getting Started pipeline. And it's going to include pulling in data and just trying some basic summarize, maybe normalize data pills. Anyway, I'm going to save that. And it says, all right, here's your list of possible data sets. Right now, we don't have any. If you came in here and added a data set through the assets bar, it used to show up just fine here in the earlier versions. And for whatever reason, I tried that and it's not working. It still doesn't show up. It wants me to add the data set from right here. So that's what we're going to do. Also, it says, by the way, there's a bunch of pre-built sample data right here. So if you switch over to the component tab, it takes you to the same place. These are all of the pills, and each of these boxes is like a pill with code that we can use to do stuff to a data set to build out the pipeline. And here's their sample data sets. You simply click one and drag it out here. And see how this looks like a pill? It has an output, and data will flow from one pill to another until it gets through to a prediction. Anyway, if you right-click on a pill, you can preview the data and see what's in there. Some adult census income. This is interesting. They've got data from a census here. I can click on a column, and it gives me a histogram of that data, which is also right here, a little preview of it, along with some basic univariate statistics. It doesn't have things in there like skewness, though, which are kind of important for certain families of algorithms that you may want to know. So as I go through and look at these, I can see what my values are, but it doesn't give me everything. So what I want to do, first of all, let's get a different data set in here. And then I want to get some more details on it. So I'm just going to click on that. Again, hit the delete button or right click and delete. Come back here to data, click the plus button, and I'm going to use the insurance data set, which I've used in prior videos. I'll put a link to it in the description of this video. You probably already have it from somewhere else. It's a CSV file. And I'm going to call this insurance. Let's see. I pulled this in earlier and archived it, so it doesn't want me to use that name. I got to give it a unique name. Insurance underscore data. There we go, that works. All right, now type. You might think, hey, I'm uploading a file, that's what it is, but that's not what we want. We want this tabular data type. Let's see, Azure ML version 1. There is a version 2 now that lets you do a file, a folder, or tabular. Either way, if you have those options, we're just going to stick with tabular. Hit next. And it says, where is this going to come from? It's interesting. The first time I looked at this, it only gave me a few options from Azure Storage, from local files, or from URI. And now it's given me some other options in here. Maybe I've created some other objects. Anyway, regardless, we're just going to go to local files. You should have that option. And we're going to upload a CSV. So it says, where do you want to upload it to? You might remember back when we made this workspace, this machine learning workspace, it by default created a workspace blob store or place for us, and it called it this name right here. It's a place for us to simply upload files. Yes, that's where we want to put it. Next. Upload files or folder. We're going to upload a file. Find that insurance data set. It's either in the book or in the description of this video. Open that. If I click on it, will it give me a preview? No, that's all right. We'll get one later. Hit next. Here's our preview. Says, all right, file format. It's comma delimited, so that's fine. Yeah, delimiter, comma, there we go. Encoding. As long as everything looks right, just stick with the default encoding. If for some reason your data, this data is going to work fine for you, but if you have a different data set and it's not looking right, it might be delimited by a tab or something else. Or if you have like free text data, there could be weird characters in there, emojis or something else, and you might have to pick a different encoding for it to read properly and look like a nice normal table like you want. So anyway, just some info if you have different data sets. All files have the same headers, so this is relevant if we have multiple files that go into the same data set. No, don't skip any rows. Keep all of it. Multi-line data. Nope, we're good. So next. It lets us double check the schema and make sure that it's reading the data types correctly. It's possible that you could look at something, for example, age, and you are expecting it to be an integer. And if this were to say string, you might not realize that in one of the rows there was text data or something like that. You might want to clean that out first so that it properly reads in as an integer. That's what I'm doing here, just scanning to make sure everything looks right. That doesn't mean I won't change the data later. For example, we'll need to dummy code text data if we want to use it in a regression model, for example. But anyway, that's not something we worry about right here. So next, looks good. Create. Give it a moment to finish that. Oh, it's all good. Good to go. So now, when we click on data, we'll see a list of our own data sources right here that are available. We could always go to component to see the sample data sources, but we're going to click and drag this out here just like we did before. I'll keep it on this side. I'm going to right click, preview data. Yep, that looks just like we're expecting. Oh, that's from we had that open previously. This is a preview pane. Obviously, that all looks good. I'm going to close that out. There's our pill. Now that we have that, notice we have this little circle at the bottom and it says data output. So every pill is going to have 0 to many inputs and 0 to many outputs. I'm going to click on component because next what I want to do is execute some code on this pill. So I'm going to go here to, well, you can just browse these and take a look. There's a variety of options, add columns, add rows. That's how we transform data. This is a kind of cool one that's in this version, computer vision, how we work with and apply images. Let's see, models, scoring, and evaluation. We'll come back to that. I want some very simple statistical functions like summarize data. Now, if you don't remember where things are, you can always just come up here and just search for them up at the top and go straight to the pill. In fact, eventually it'll be a lot faster to do things that way. All right, so summarize data comes in. It's got one input, one output. Input, if you hover over it, it's expecting what it calls a data frame directory. It wants data. If you hover over this, the output says data output ML table. That's what it's looking for. If I click on this little output, it lets me connect to that input. And it says, yeah, that'll work. It changes from red back to normal color. And what this means is that data will flow from this pill into this pill. Now this pill just performs some functionality. It's going to go through and create a bunch of univariate statistics on the data for us. It then passes out the results of those statistics. So we're going to click Configure and Submit, which is going to check and say, all right, if you want to run this model, you have to create an experiment. Experiments show up here under Jobs because we want to keep track of every experiment we run. So an experiment is going to say, yep, go ahead and let the data flow from here into this pill and process both of these pills. So we don't currently have an experiment, so we're going to create a new one. And we're going to call this the Getting Started Experiment. Job display name, that's fine. Review and submit. You can give it tags if you ever want to search for things. I'm not going to worry about that. Hey, but I got a problem here. Runtime settings. It says, please select a default compute to run a pipeline. So this is why we created that compute instance in a prior video, is that in order for it to perform this processing, it needs a virtual machine to run it. Right now, it's been providing this web service, this website here all for free, but it takes some serious power to process this data. So rather than do that for free, it wants us to sign up for a compute instance, which we did, so that it can charge to our $100 student credit. Anyway, just come down here, change it to compute instance. It's kind of a cluster is something more powerful and scalable. We don't need that, plus we don't have access to it on the student account. We're going to instead just grab this one that we set up running earlier. Data store, it says where do you want us to store the results? Same place where we put the file. Yep, it's all good. Next, review and submit, submit. All right, so while that's running, shouldn't take too long. While it's submitting first, it's going to validate it, which we could do right here without actually running the experiment. But configure and submit means validate it, which is done, and then show us the details. That means it's created a experiment run here under Jobs. If I click on View Details, it's going to open up a new window, which basically just takes me to this Jobs feature here. And it looks just like where we were. Notice if I go back to that page, I'm here on the designer mode. This is just the conceptual design of the pipeline. This is the actual pipeline run. And you can see right here, it's showing you that it is currently running. And this can take some time, depending on how much data there is and how much you're doing. Shouldn't take too long for this. In fact, the green, I think, means it's about done. There we go, completed, it says. So job details, I can click on that, or if I can also just right click on this and say preview data. This means preview the output of this pill. If I just click directly on that circle output, it just takes me right to preview data. And I'm going to stretch this out. And it says, cool, here's what we've got. The columns that used to be across the top are now feature names down the row here. Gives us a count, unique value count, missing value count, the min, the max. I've got NANs because this feature is text. Has two total values, male, female, and min and max don't apply. But I've got a bunch of other things in here. Do I have a way of scrolling through? Let's see if, there we go, right arrow. Quartiles, median mode, range, sample variance. Here we go. I'm kind of interested in this, sample skewness. You might remember from a prior chapter in this data that charges, insurance charges is positively skewed. So we're outside the bounds of -1 to 1. That's what the summarized data pill does for us. But that's the process of starting in the designer. And notice now if I click on designer, it gives me a list of experiments that or designs that I've started. And this is a training pipeline. If I click on that, it takes me back into this view. But this is not where I go to look at my results. This is just sets up the conceptual experiment. I have to go to jobs, and I can see here's the job that got created, or the experiment that got created when I ran that pipeline. I gave it the same name. I click on it, and I've processed it once. And so it shows up right here. Gives me a summary of the pills within that. This is just a different view of the same thing. I can get there by clicking on this name, and it'll show it to me. Here's the version where you can see the green check. It's run, and again, right click, preview data. That's where I get in and see the results. All right, let's try one more pill of a different type. So I'm going to move this over. And if I want to edit this and make a new pipeline, I can't do it here in jobs. I need to go up here to, in fact, I'm going to leave this the way it was. That was pointless. Instead, I'm going to go back to the designer, and I'm going to modify this. And I'm going to grab another pill, data transformation. There should be a normalized data pill. They might have gotten rid of it because now they auto-normalize everything. Maybe I'll just search for it. There it is, normalized data. So I'm going to pull a separate arrow from insurance data, just so you can see that it can go to more than one location at once. And notice I get this parameters option. I didn't have that with summarized data. There are no parameters or modifications here with this pill, but in this one there are. It says before you can run this, there's parameters you have to edit. In particular, it wants to know which columns are you going to transform. All right, sounds good. I'm going to click on this, and they've changed it a bit. Do I double click on it? Maybe I double click on this. Oh, there we go. So that was, let me show you again. This is a preview of the currently set parameters. So it's saying what type of normalization technique do you want to use. It defaults to z-score. That's kind of less common now. We usually use min-max, so I'm going to change that. Use 0 for constant columns, which, yeah, never mind. And then which columns to transform. Currently no columns selected. So in other words, we're getting a red alert here because it's saying you've got to select a column before you can run this. Double click on the pill, and now it takes us to where we can edit those parameters. So let's change z-score to min-max. Notice you've also got some other common options like 10H, log normal, logistic. Anyway, I'm going to click here on edit column, and by name, I like this view better. And I can click, I don't want to add all, I only want those that are numeric. So age, BMI, children, charges, save. Okay, so these are the columns that it's going to apply a min-max transformation to. That looks good, so I'm going to collapse this. And now notice it shows up here. Here's the columns I've selected. It's changed it to min-max. I can minimize that. And I want to show you the difference now between what these two types of pills do. Both are a set of logic that transforms the data into some other form. Summarized data transforms it into a set of statistics, whereas normalized data is really just letting the insurance data flow through after getting slightly transformed, but it's still the same data set and the same structure with each row representing a case. Anyway, let's just run it. So I'm going to click review and submit. I think everything should be fine because it's going to use the same same experiment name. We could make a new one, but there's not really a need for that. Oh, select existing. There we go. I don't want to make a new one. Display job name. So it's going to overwrite my last one, and I don't really need to keep a history of that last one, so that's why I want to overwrite it. Next, next. Same compute instance still running. Looks good. Submit. Okay, let's make sure that it validates here. That part doesn't take too long. Okay, again, I can click view details or just go straight down here to jobs. Same thing. It is still using, I set it to use the same experiment as before, so it's just overwriting this one. And not overwriting, I guess, but using the same group. And now it's got the prior version I created right here, still kept in history. And then my new version right here, still running though. So last one took 43 seconds. I expect this will take a little bit longer, but let's go ahead and break this down, and you can see it's finished this pill already. Usually it's pretty smart about using a cached version from a prior one, so it probably just grabbed the results from this summarized data and put it right here. And now it's running this normalized data. Anyway, I'm just going to click here on getting started to drill in. And we'll let that keep running. All right, that wasn't too bad. In fact, let me just see, though, how long that actually took out of curiosity. 58 seconds. Okay, could be worse. All right, so summarized data is the same. I'm not going to change that. But normalized data, notice we have one input. It needs data, and then two outputs here. So this one says a transformed data set and a transformed function. All right, well, let's take a look at what both of those are. Transformed data set, first of all. Stretch this out. And notice we've got the same columns, but now they're in a new format. This is in a min-max, which means it's going to range from 0 to 1. So it standardizes or normalizes the data to that scale. This is useful for some algorithms, not for others. I just wanted you to see how it works to transform data and pass it through. We don't normally have to actually have this normalized data pill. in our modeling, because when we train models, when we get to that point, it will automatically normalize data for us. But I just wanted you to see the process and how it works. Let's go ahead and take a look at what this transformation function is. I doubt it'll give us a whole lot. Yeah, it's just kind of giving us the code, I guess, for how it went through the transformation. Interesting. Not super important to us, though. I'm just going to close it out. All right, so let's stop here for now. This is pretty good. We've created a designer, which includes the conceptual design, and we've only got one so far. We'll save this one and create a new one in the next video. We get the idea of pills. Each pill has logic. The logic of this is just to pull in the data. The logic here generates a set of univariate statistics. Logic here is it transforms the data but continues to pass it through this side right here. And then we get the idea of a job, which is an instance of computing or running that designer. And it keeps a historical record of each one that gets run. All right, let's stop there.